This is a Math 1 lesson summary video for the lesson titled Which Fits Best. This is a practice understanding task. The purpose of this lesson is for students to fit linear and exponential regression models to data and to solve problems. So in this video, we're going to review finding a linear regression equation and show you how to find an exponential regression equation and how to use those equations to find a value. So let's go to Desmos, where I have already entered our Netflix data, and with this one we'll find a linear regression model. So for the linear regression model, you have to, of course, have your data entered in first. And I have already pushed the little zoom fit button so that I can see all of my data right here. For linear regression, I need to pay attention to how my variables are labeled. My output here, I put an N for Netflix, so I'm going to put N, and then a tilde, and then I want the slope, so that's M for slope, and then I need to look at what my independent variable is labeled as, and it's X sub 2, so I'll type X2, and then plus B for y-intercept. And here I have my parameters. There is my slope and my y-intercept. So I have an equation. So my equation would be y equals 6 point, I can round that to, let's just say 453, x plus 93 point, I'll round that to 777. So you can see that this is the same line. All right, so we're going to take this process and do an exponential regression. So I'll hide what I have here and put the Under Armour data. And I'll click this little plus to zoom fit so that I can see it. Now this data, as I'm looking at it, here's my y-intercept, and this looks like it curves a little bit. So let's try out an exponential regression. So I'm going to enter an expression, and I want to be able to see my data. So let me just slide this up. Okay, now I have it all on the same screen. So exponential equations are written as y equals a times b to the x. That's how they're written, just like that. So what I want to do is I want to pay attention to my variables. My y coordinate is labeled as u, so I'm going to put a u. Because I want this to do exponential regression, I'm going to change my equal sign to a tilde, and then I need to make sure that I have my x labeled correctly as x1. Alright, so here I have my parameters for a and b. So if I want that equation, I'll write y equals, and then a for my y-intercept, 8, and then b for my rate of change, and my rate of change is less than 1 because it's decreasing, and there I have my exponential equation. Alright, so using exponential regression for the Under Armour data that we have, let's predict the stock value for Under Armour on October 1st, 2017. Now we just used Desmos to find our equation, and that's what we got when we did the exponential regression. Typed these values in and used the steps to do exponential regression. Now October 1st, this data is in months since July 1st, 2016. So from July 1st, 2016 to October 1st, 2017, that would be 15 months. So 12 months to get all the way back over to July, and then 3 more. So what I'll do is I'll put 15 in for X. So I have $10.82 for the stock value. And when I do this, I do want to check to make sure $10.82 is reasonable, which it looks like it is since my values are decreasing. Let's take a look at one more example. Using linear regression, predict the stock value of Netflix for October 1st, 2017. So I'll start with the equation that I found using linear regression. Substitute the 15, and I have $190.57 for the predicted stock value in Netflix on October 1st, 2017. So when I do this, I always like to go back and look at my data, make sure that it makes sense with the trend. So here it was increasing, that makes sense. Alright, that's it for this video. Thank you for watching.